Welcome to another session with me, Varun, on TechTablet. And in this session, let us understand the second part of linear regression exactly from where we dropped off in the last session. Right? So, going forward, let us understand two very important aspects in this agenda. The first one would be to look at the assumptions of linear regression, and the second one would be the case studies. Right? And as you all know, my name is Varun, and I've started my career with SAP ABAP, moved on into SAP UI5, started working on this YouTube channel that we are all looking at, that is TechTablet. Then I moved a bit on towards my passion, that is I started my own YouTube channel with the name Hi Chora, which is a channel for rap videos. You can also follow me on Hyderabadi underscore Chora if in case you're looking forward to talk to me, or if there's any queries that you have. This is my Instagram profile, and I currently work as a data science trainer and freelance data science developer. Yeah. So now let us focus on the assumptions of linear regression, guys. Now here, when you talk about linear regression or the assumptions of linear regression, the regression model should be linear in parameters. Now this is a very important point. If it is not linear, then there's no point. And how do we check the linearity? You can check that using a scatter plot. All right, and scatter plot is generally all like dots and points. All right, now the mean of residual should be 0. The homoscedasticity of residuals, or you should have equal variance. Now this is something that we know, and there should not be autocorrelation of residuals. Now if in case you have autocorrelation of residuals, then there is a problem. Then the x variables and the residuals should be uncorrelated. There should be no relationship between each other, or between the residuals, because or you can say, the correlation should be as low as possible, because higher the correlation, you'll see that more is the dependency between these variables, which is not something that is expected when you're working on any machine learning algorithm. Then the number of observations must be greater than the number of x's, which is your dependent and independent variables. Now going forward, the variability in x value should be positive. Well, I don't think this needs any explanation. No perfect multicollinearity and normality of residuals, guys. Your residuals should be normally distributed, which is again, which would again bring us back to the homoscedasticity concept. Now, talking about the ground rule, or the formula behind linear regression, as you can see, there should be linear or additive relationship between dependent variable and independent variable. Now, when I say dependent, it is also called as response. Independent is also called as predictor. Dependent is called as response. All right. Now, a linear relationship suggests that a change in response to y. Now, this is y-axis and this is x-axis. A linear relationship suggests that a change in response y due to 1 unit change in x is constant. Okay, now this is y and this is x. And regardless of the value of x, an additive relationship suggests that the effect of x on y is independent of other variables. So here you can see this is how the equation is also y equal to mx plus c, or y is equal to beta x plus c, wherein beta you have beta 1, beta beta, and x would be repeating, and c would be a constant. All right, so this is how your linear regression equation is spread out to be, or this is how you understand it. Now, going forward into it, what do we mean by no multicollinearity? Right now, multicollinear is a very important feature that you should eliminate. Okay, so you can see there should be no correlation between the residual. Residual means error. Okay, I think it's already written in the bracket here. So residual terms. Absence of this phenomenon is called as autocorrelation. Now, the independent variables should not be correlated. An absence of this phenomenon is called multicollinearity. Now, both of them are very important, guys. So the first one says the independent variables should not be correlated, and there should not be correlation between the residue of the errors also. So correlation and collinearity. I hope now you understood the difference between them. Now, going forward, what is homoscedasticity? So here you can see I have pictures available. These are some pictures that I've spotted in Google. Guys, I've not designed these photos. So these are photos that I've picked up from Google to probably ease the understanding. So here you can see there is heteroscedasticity. Here also is a case of hetero, but this is homo. And what is the difference between them? You see here that the error is randomly distributed. Here we can see that there is a pattern in error distribution, and patterns are not recommended. So here that's exactly what it is. The variance of errors should be consistent for all the observations. This condition is known as homoscedasticity. If the variance changes, we refer to that as hetero. See, this is hetero. The validity of this assumption can be checked using this plot, guys. The name of the plot is fitted versus residual plot. It's a very, very important interview question. If someone asks you how would you check the homoscedasticity, then now you have an answer, and the answer is fitted versus residual plot. So you would be using this plot, and in this plot, if it is cone shaped, then the spread of residuals increase in one direction, which means that heteroscedasticity is present, which is not favorable. All right, going forward, the residuals should be normally distributed. As you can see, how do we know if they're normally distributed? In order to do that, you can do it using QQ plot or a histogram. Either of them would do the same thing. And normality can be checked with a goodness of fit test called KS test, which is also, I'm not very sure of the spelling, but let me give it a shot. Kolmogorov, I think it's Shmanov test. Well, I'm not very sure, guys, but yes, I think it's a pretty Russian kind of name, and this is the test that we use in order to check. And here you can see I have a bell curve, which means that, oops, that's not how it was supposed to be. You can see, anyways, I think I'll just hash it out. You can see that I have a bell curve here, and this bell curve shows that your data is normally distributed. And when your data is not normally distributed, a non-linear transformation has to be performed, which would then fix the issue. All right. Now, going forward, we look at some case studies. So guys, it's used in environmental sciences, wherein it finds the application in wide range of environmental science applications, wherein you are trying to monitor the statistic analysis on fish and benthic survey to measure the effect of pulp mill, or to measure the effect of metal mine on the aquatic ecosystem. So here you can probably come up with a sample or an explanatory graph. This is the pollution discharge, and this is the fish. So I see that greater the pollution that's getting discharged, greater number of fish are dead. So the relationship is direct. Here I have a score prediction. I'm trying to predict the number of runs a player would score in coming matches based on previous performances. Now, guys, please do not mistake this to be time series. Here we are not forecasting for future. All right. The next one is salary estimation. An organization can use linear regression to figure out how much they would pay a new joinee based on the years of experience, because based on the experience, his salary would increase. So that is how the relationship is described, or the relationship is understood. So guys, these are some case studies that I have for you. In the upcoming videos, there's also a lot to watch. We have logistic regression lined up. Then there's decision trees, random forest, KNN versus K-means, decision trees versus random forest, a lot of differences and examples. And not to forget, if in case you've liked the video, then guys, please hit the like button. Also, do use the subscribe button, because when you do that, you would have access to a plethora of videos. And also there's this bell icon. Do hit the button without forgetting. And do share this with your friends if you find this video useful, because if you do that, And if you really find this video useful, I think it will help at least one or two learn what they want. So thanks a lot for your patience. Thank you very much for being there. This is me, Varun, your trainer, your mentor, signing off. Have a great day and all the very best.